So what types of things could be a mirror?
This microwave oven. This counter.
My glass cup.
This television.
My scalding hot cup of tea.
The cat's goggles.
You see, a mirror can be any smooth object, such as a countertop or a glass cup, because they reflect light evenly. But objects such as a house cat are rough and uneven, and therefore cannot be mirrors because they do not reflect light evenly.
The law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection.
In this demo, Adam, holding the video camera, and Natalie are standing at certain angles relative to the mirror and can see each other.
Hi!
But when Adam changes his angle by moving closer to the mirror, she disappears. What happened? Whenever you see into a mirror, there is an angle of incidence and an angle of reflection. When Natalie stands in Adam's angle of reflection, they can see each other. However, if Adam changes his angle relative to the mirror, then both angles are changed and they can no longer see each other. But why does a mirror reflect all energies and colors of light? When a photon of light hits a mirror, it causes the electrons in the atom to vibrate and give off an identical photon of light.
By the way, light itself is invisible until it bounces off something and hits our eyes.
If this is a photon of light, it will bounce off of an object and hit you in the eye, like this.
Ow!
Now we are going to examine the difference between specular reflection and diffuse reflection.
When light bounces off of a smooth surface, its reflection is called specular reflection. This is what happens with mirrors. When light bounces off of a rough surface, it reflects as if there are smooth tangent lines. This type of reflection is called diffuse reflection and creates an uneven image such as a cat.
A convex mirror, which bulges outward, reflects at a wider angle near its edges than its center, creating a distorted image smaller than its actual size. Concave mirrors curve inward like a spoon. From far away, objects will appear upside down, but as you get closer, the image flips and magnifies. Just a fun fact, concave mirrors are used to light the Olympic torch. Normally, you have to point this infrared remote at the TV in order to turn it on. But what happens if we point it away from the TV at a white piece of paper? Let's find out.
Fool, you lose. He's the one that's upside down. You better come into my frame of reference. All right.
In this demo, infrared light bounces off the white paper back towards the TV to turn it on. Now let's find out what happens if we point the same infrared remote at a black piece of paper.
The TV doesn't turn on because when you point the remote at the black piece of paper, the infrared light is absorbed. But when you point it at the white piece of paper, the infrared light is reflected onto the TV receptor. For our first project, we made a periscope. A periscope is a tubular-shaped object that has mirrors at the top and bottom at 45-degree angles. Light travels into the periscope through the top, is reflected off both mirrors and onto your eye. In this way, periscopes can be used to see above, below, or around objects depending on how it is oriented. The periscope is a very useful object for a variety of things. Not only is it used in submarines, but also you can spy on your neighbors and your
friends over fences.
Our next feat was to make a pseudoscope. Here's a picture.
This is our pseudoscope. I can see the light from the green pen bounce off of this mirror and this mirror so that I'm seeing it through my left eye. I can see the pink marker bounce from the light from the pink marker bounce from this mirror to this mirror, so I'm seeing it from my right eye. Wow, the images are switched.
Lastly, we made a kaleidoscope, which looks like this.
What I'm holding here is a kaleidoscope, which has mirrors on all 3 walls. When I put it on, I will be able to see myself many, many times. Wow, this is amazing!